And back to chapter 20, last part. A little case study. Southeast Asia, of course, they have what's known as the Asian brown cloud, which is pollutants, smog, that can be up to 2 miles thick. There's no doubt China and India right now, there's huge industrialization going on. Their middle class is picking up big time, burning more coal, putting in more coal-burning plants at a phenomenal rate to have more of a decentralized system, which is much more efficient. However, they're polluting big time. That pollution's reaching all the way over to California right now. Dust from the deserts, of course, another lung irritant or pollutant. Their solar energy, actually, they're blocking their sun because all these pollutants is reduced 2 to 15%, which is going to affect their agriculture and trees and lakes. They have huge brown clouds that actually can warm some area because it keeps the heat in, and actually cools others because it doesn't allow the sun come through, and actually has shifted rain patterns. Can be reduced, of course. They could burn gas, they could filter their coal with scrubbers much easier, or even use wind or hydropower. Acid deposition, just think of it as acid rain. Deposition means it's coming out of the sky and going onto the ground. It's depositing. Coal burning plants or smelters are infamous for burning lots of coal and releasing this. The United States is much better at this than other nations right now. Sulfur dioxide, nitric oxides rather, particulates make acidic chemicals. Of course, what happens is SO2 eventually can lead into H2SO4, which is acid rain, and NOx's can actually lead into HNO3, which is nitric acid. Then what happens is it travels. We know that happened in the Great Midwest, and it traveled to Canada at one time before our Clean Air Acts and destroyed their trees. Some places have remedied this by, hey, let's just put a smaller, taller smokestack up. The problem with that is it just puts it in somebody else's backyard. It can remain in the atmosphere for up to 2 to 14 days, and of course, as I said, return as nitric acid and sulfuric acid. We can get wet deposition or dry deposition. Wet deposition is when it rains, it snows, it's fog, so even the snow around here can have acidic effects, and I'll show you a couple things that can cause. Technically, acid rain is at a pH of below 5.6. Dry deposition is when we have acidic particles just kind of floating in the air. Havoc too. So acid deposition, what happens, as I said, from industry, from agriculture, we have that nitrogen actually get up into the atmosphere and cause nitric acid. We have nitrates coming from cars, from burning like this, getting up and making that nitric acid. And of course, we can get sulfuric acid from burning things like coal into the atmosphere, which is terrible. Taking a look at the United States, of course, you can see where most of the acids are, and that happens to correlate with most of the industry. East of the Mississippi River, basically, right here, is where most of the heavy industry is, particularly in the Steel Belt region right here. Burning a lot of coal, creating a lot of borders. It goes into Canada very easily. Soil oftentimes gets hit big time with this, and we get increased dissolving of metals that are in the soil. We can neutralize it with calcium carbonate, but how are you going to neutralize an entire forest or entire agricultural region? There's a lot of sensitive areas that are vulnerable to acid deposition, areas that have very thin soil, maybe areas that have where there's buffering chemicals have been depleted. So we do have buffering, things like limestone that naturally occurs in our soil, but if it's been depleted, boom, done. One country, of course, their problem becomes that of another place with ours. A couple areas that we have potential problems because of sensitive soils. In other words, they don't have a real thick topsoil layer, and they don't have great decomposition, so it's really slow. Like in Canada, Canada's growing season, thus their decomposition season too, is much lower than ours. If you take a look at the eastern coast of the United States, even up into Canada, and we're causing a lot of that too. Europe, of course, causing a lot because we're burning critical areas. So this acid deposition can cause everything from respiratory disease. It can actually attack metals and stone. Lady Liberty out in the New York harbor, of course, actually had to be redone in recent years because of acid rain. It actually started to erode and corrode her and change her color, basically. Over in Europe, where they've had acid rain for a lot longer years, their statues that had faces are actually losing their faces because of the acids. It can kill fish, can decrease atmospheric visibility, can actually affect plants. It can leach magnesium and calcium out of the soil, which plants need in order to survive. Then, of course, herbivores, which don't get the calcium in them, don't have bone strength. It can dissolve those metals, of course. Mountaintop trees are oftentimes because of the jet streams. You can see that right here, where we get acid deposition. We get all these pollutants, these primary pollutants in this case too, that combine together and cause acidity and leaching. How can we reduce acid deposition? Well, a great start in 1990 was an amendment to the Clean Air Act, and that really fought to rid of pollutants, including nitric oxides and sulfur oxides too. We've had a national acid precipitation assessment program where people, like, you can actually go out and measure acidity of different lakes and even soil around the region to try to track that and reduce it. We need about 80% reduction for northeastern streams to recover, though. Again, in this area down through Chicago, Pittsburgh, and so on, a lot of that gets up in the atmosphere and gets into the northeastern part, like Maine, Vermont, New Hampshire area, and of course wreaks havoc up there. The best, which is politically motivated, is eliminate SO2 and NOx's, and that is very politically loaded. We need to lower our sulfur coal. Remember, there's a couple types of coal. There's anthracite and bituminous. Bituminous actually has a higher sulfur content. That's where we tend to burn more now. Anthracite is better, but we can't find it as much. It's not as readily available. And of course, that releases mercury, CO2, and radioactive particles into the element too. We could add limestone to do it on such a large scale. Indoor air pollutants, kind of the last idea here. We're actually at a much greater risk for indoor air pollutants. We don't get as much air circulating inside. Plus, we're inside quite a bit. Most of our time is spent in cars and homes. Think about, the picture on the bottom, this poor baby right here. What happens is dad is smoking a cigarette, probably with the windows closed, and that poor kid is getting secondhand smoke. We get sick building syndrome. A lot of times new buildings have toxins in them that are slowly releasing out. A lot of times, because we reuse air in buildings or airplanes or even ships in the ocean, cruise ships, what happens is if one person's sick, it can affect lots of people. Cigarette smoke, formaldehyde, radon, ultrafine particles are what we're going to talk about. Just sitting in your house, you're getting lots of different things. A couple different things is from furniture, actually from your flooring, you get formaldehyde. Formaldehyde is actually a body preservative. It's a cancer-causing agent. Somebody smokes in your house, you're breathing that in constantly. Through this region, because of our granite structure, we actually have radon-222 that's naturally emitted into your basement, so you should have a system to negate that. Some houses that are built 1950s, 1960s actually have asbestos that's being emitted. Formaldehyde, the first one, it's a colorless, irritating gas. About 20 to 40 million Americans get affected by this. This actually seeps out of your floor. It's actually used as a preservative in your flooring, and it preserves the wood really well so it doesn't rot and get moldy, but it can actually cause dizziness, rash, headaches, and sore throat. Again, it's in building materials. It's in the wood in your house in general. It's in fingernail hardener. It's actually wrinkle-free clothing, too. Radon-222, as I said, it's a naturally occurring thing. Actually, in southeastern Wisconsin, occurs quite a bit. We've got granite structures down here. Our foundation, and what happens is that granite naturally leaks radon-222, and that's actually causes lung cancer. It gets in from the cracks in your flooring up into the system to help that. So it can be from the decay of uranium-238. Is a carcinogen. It's pulled into homes due to pressure differences. So there's high pressure outside of our homes and inside. Boom, it gets in your house. Really should test your house for radon, particularly if you spend lots of time in your basement, or if you have a bedroom, particularly in your basement. Steel cracks foundations, and you can actually moves it out. Ultrafine particles are things that probably don't even think about that we breathe in. Everything from smog to tobacco smoke, soot. Common things are even like dust, settling dust in your house. Cat, if you have a cat and you're allergic to it, obviously that causes a lung irritation. Viruses can affect this. Dust mites affect a lot of people. Bacteria, mold spores, pollen, things like that. Very small thing, very big scale. Respiratory system, of course, you've got hairs that are in your nose, that not the ones that are sticking out, but the little cilia that actually take out pollutants before it gets in. That's why you have mucus in your nose too. That's why you're supposed to sneeze that stuff out when your body says to. Prolonged exposure can break down natural defense system. It can weaken your immune system. We can get things like asthma, lung cancer, bronchitis. We know air pollution kills about 3 million people yearly, indoor, really, in developing nations, particularly because a lot of their houses are heated with like burning coal or burning wood, and they also cook over that too, so those pollutants get out in the atmosphere in your house and you breathe that stuff in. EPA has standards for diesel vehicles as of 2007 and want to reduce emissions by happening with cars now too. There's new laws with cars. First of all, we actually have this thing called a catalytic converter, which is actually between your engine and your exhaust, and it collects all that bad stuff before it gets out into the environment. And we're getting much better in the United States about these laws. We had the Clean Air Act, of course, which helped a lot. 1970, there were amendments in 97 and 90. We have a National Ambient Air Quality Standard, also known as the NAAQS, which has 6 outdoor criteria. Really, the standard of this is to protect human health, and secondary is to protect environmental and property damage. Of course, the biggie is that we want to EPA has standards for 188 hazardous pollutants called HAPs that cause serious ecological health concerns. We go after things like neurotoxins, carcinogens, mutagens, and teratogens, which we talked about earlier. Most chlorinated hydrocarbons are bad. VOCs like gasoline, bad. Most pollutants have decreased in the United States because of those Clean Air Acts. A lot of citizen pressure, obviously. Better efficiency of things like cars. If we go eventually even to hydrogen cell cars, if we can get there with our technology, water vapor comes out the back. And we're affluent enough to afford a lot of this too. 2 HAPs, hazardous pollutants that increased in recent years, unfortunately, mercury and dioxins, again from the burning of coal and from industry. Both very toxic at low levels. About 100 million people live in areas where the risk of cancer is 10 times higher than the acceptable level because of the level of industry. Unfortunately, continuing, we do rely on pollution cleanup rather than prevention. Precautionary principle, we should prevent it before it gets into the environment. Congress not fully aboard on this, of course. We got to get better on fuel efficiency, although that's moving in the right direction with cars. 2-cycle engines are still allowed. 2-cycle engines are like on mini bikes, or maybe if you have a weed whacker at home, it's a 2-cycle engine, kind of that blue smoke comes out of it, and that isn't regulated by these laws, and that sends out a lot of pollution. Ocean-going ships are not regulated, and if you've ever seen I've seen one of those, the diesel fuel that comes out of it is just terrible for our environment, black smoke coming out, and a lot of that is because there's international laws that really aren't supported. We're not doing much about greenhouse gases. We'll talk about that more in chapter 21. Indoor pollution is still a big problem, particularly in poor nations. Unfortunately, that Clean Air Act is always in force. So the Clean Air Act of 1990, good thing, did allow emissions trading, good and bad, I should say. It actually allowed it what's called a cap and trade program. So what this did was allows a company to buy credits, if you will, and say, okay, I'm going to emit X amount of sulfur dioxide into the atmosphere, and the government's okay with that. So they buy it from the government. Okay, the government should take that money and try to research some new ways to get it out of the environment. But the bad part of this is they can actually sell it to other countries, or other companies rather. So what oftentimes happens is a company may buy it in Indiana, for example, but then sell it to a company in Ohio. So then in Ohio, a company buys it there and gets all these credits and does lots of polluting in one isolated area. Clean up equipment to remove scrubbers. Make sure you know about scrubbers. What they do is they clean toxins before being released in the environment. This is a scrubber right here. And what happens is it's probably a pollutant is coming into there. It cleans everything out before releasing up into the environment. United States law dictates that. Industry has already, in business since 1970, met a lot of the clean air standards. Anything new that's built has to meet it. In 1977, the Clean Air Act did require old plants to upgrade. Many plants did avoid doing that by calling the expansions maintenance, and in 2002, President Bush actually relaxed the requirement for older facilities. So those older facilities in the United States have gotten away with it, kind of been grandfathered, and what's happening is polluting. Reducing pollution from cars, as I mentioned before, actually, we did pull older cars off the road. The Cash for Clunkers program, which you may or may not remember underneath President Obama, pulled a lot of those very polluting bad cars off out of the circulation. The problem is a lot of them were sent to third world countries, so we're still getting pollutants in the world. Catalytic converters, make sure you know that. That is one of those things that cars have that protects and takes all the pollutants before it gets out in the atmosphere. Hybrid cars, good. Obviously, zero emission cars, great. Developing countries, of course, still have those old cars that pollute, and of course, it can end up in our backyard. So that's it for chapter 20, and take care.